aromatic, antiaromatic and non-aromatic compounds. Well, I will teach you super easy trick to find aromatic, antiaromatic and non-aromatic compounds. Now let me teach you the easy concept of conjugation. If a compound contains double bond, single bond, double bond, it is a conjugated compound. Secondly, if a compound contains double bond, single bond and positive charge, we say that it is a conjugated compound. Thirdly, if a compound contains double bond, single bond and a negative charge, we say that it is a conjugated compound. Fourthly, if a compound contains double bond, single bond and a lone pair of electrons, we say that it is a conjugated compound. For example, consider these organic compounds. In this organic compound, we can see that this organic compound contains double bond, single bond and a positive charge. I write 1, 2, 3. It follows the second rule, so it is a conjugated organic compound. Secondly, in case of this organic compound, we can see that it contains double bond, single bond and double bond. I write 1, 2, 3. This organic compound follows the first rule, so it is conjugated organic compound. Thirdly, in this organic compound, we can see that there is a double bond, single bond and a negative charge. I write 1, 2, 3. This organic compound follows the third rule, so it is a conjugated organic compound. Fourthly, in this organic compound, we can see that there is double bond, single bond and a lone pair of electron. I write 1, 2, 3. This organic compound followed the fourth rule, so it is conjugated organic compound. So note it down this important example. Now consider these organic compounds. In this organic compound, we can see that there is double bond, single bond and there is another single bond. I write 1, 2, 3. Here at the third position, there is no negative charge, no positive charge and no lone pair of electrons. It doesn't follow any rule, so it is not conjugated organic compound. In case of this organic compound, we can see that there is double bond, single bond and double bond. I write 1, 2, 3. This organic compounds follow the first rule, so it is conjugated organic compound. In this organic compound, there are two lone pair of electrons. Remember that this lone pair of electron is out of the ring. So we say that this lone pair is outside and this lone pair is inside the ring. Remember that if the lone pair of electrons is outside the ring, we do not consider it in the conjugation. Let me repeat it. If the lone pair of electrons is outside the ring, we do not consider it in the conjugation. We only consider the lone pair of electrons which is inside the ring. So this organic compound contains double bond, single bond and a lone pair of electrons. I write 1, 2, 3. This organic compound followed the fourth rule, so it is conjugated organic compound. Lastly, in this organic compound, this lone pair of electron is outside. So this lone pair of electron doesn't participate in the conjugation. So we do not consider it because it is outside the ring. We can see that this organic compound contains double bond, single bond and double bond. I write 1, 2, 3. This organic compound follows the first rule, so it is conjugated organic compound. Just note down this easy method to find the conjugation of any organic compound. Now let me teach you the basic concept of aromatic, antiaromatic and non-aromatic compounds. Aromatic compounds and antiaromatic compounds are those compounds which are cyclic, conjugated and having planar shape. By planar shape, I mean they must have 2D shape or they must have sp2 carbon. Remember that those carbons are sp2 hybridized if they contain only double bond. On the other hand, non-aromatic compounds are those compounds which are not cyclic, are not conjugated. For example, consider these organic compounds. We can see that this organic compound is cyclic, so the first condition is fulfilled. Secondly, we can see that it contains double bond, single bond, and positive charge. So this organic compound is also conjugated. Thirdly, this is a planar organic compound. So all the three conditions are fulfilled. So this organic compound is either aromatic compound or anti-aromatic compound. Secondly, this organic compound is cyclic. It contains double bond, single bond, double bond, so it is also conjugated. Thirdly, it is a planar organic compound because it contains a carbon having sp2 hybridization. So this organic compound is either aromatic organic compound or anti-aromatic compound. Thirdly, we can see that this is not cyclic organic compound. So it is non-aromatic compound. Fourthly, this organic compound is not cyclic. So it is also non-aromatic compound. Fifthly, we can see that this is a cyclic organic compound. So the first condition is satisfied. Now we can see that it contains double bond, single bond. At the third position, there is no lone pair of electron, no negative charge, and no positive charge. So this organic compound is not conjugated. Therefore, this is non-aromatic compound. Thus remember that if a compound is cyclic, conjugated, or planar, it is either aromatic compound or anti-aromatic compound. If a compound is not cyclic, not conjugated, or not planar, it is non-aromatic compound. Now I will teach you the super easy trick to find aromatic compounds and anti-aromatic compounds. For aromatic and anti-aromatic compounds, I write 2, 4. Now listen carefully. I add 4 to this 2 successively. 2 plus 4 is equal to 6. 6 plus 4 is equal to 10. 10 plus 4 is equal to 14. Similarly, I add 4 to this 4 successively. 4 plus 4 is equal to 8. 8 plus 4 is equal to 12. 12 plus 4 is equal to 16. Remember that these 2, 6, 10, 14, 4, 8, 12, 16 represents the number of pi electrons. We already know that aromatic compounds are those compounds which has 4n plus 2 pi electrons, while anti-aromatic compounds are those compounds which have 4n pi electrons. Also note it down that for each double bond, I will write 2 electrons. For each negative charge, I will write 2 electrons. For each lone pair of electrons, I will write 2 electrons. Remember that for positive charge, I do not write any electron. Now consider these organic compounds. We can see that this organic compound is cyclic. Secondly, this organic compound contains double bond, single bond, and double bond. So it is also conjugated organic compounds. Now inside the ring, there are 2 double bonds. We already know that for each double bond, I have to write 2 electrons. So I write 2 electrons plus 2 electrons, which is equal to 4 electrons. We know that if organic compound contains 4 electrons, it is anti-aromatic. So this organic compound is anti-aromatic. Secondly, we can see that this is cyclic organic compound. Now here, there is double bond, single bond, and positive charge. So this organic compound is conjugated. Inside the ring, there are two double bonds. I write 2 plus 2 is equal to 4 electrons. We know that if compound contains 4 electrons, it is anti-aromatic. Thirdly, this is cyclic organic compound. Here, this organic compound contains double bond, single bond, and negative charge. So it is conjugated organic compound. We can see that this ring contains two double bonds. So I write 2 plus 2. But wait a minute. This cyclic organic compound also contains negative charge. We already know that if a ring contains negative charge, for each negative charge, we have to put 2 electrons. So I write here 2 electrons. Now 2 plus 2 plus 2 is equal to 6 electrons. We know that if a compound contains 6 electrons, it is aromatic. So this compound is aromatic. Fourthly, this is cyclic organic compound. Also, it contains double bond, single bond, and positive charge. So it is conjugated. We know that for each double bond, we have to write 2 electrons. Now 2 electrons is equal to 2 electrons. We know that if a compound contains 2 electrons, it is aromatic. So this compound is aromatic. Hence note it down these basic examples of aromatic compounds and anti-aromatic compounds. Now consider these aromatic compounds. This aromatic compound is cyclic. Secondly, it is also conjugated. It contains one double bond, so I write here 2 electrons. According to the rule, if a compound contains 2 electrons, it is aromatic. So this compound is aromatic. Secondly, it is cyclic and it is conjugated. For this double bond, I write 2 electrons. For this negative charge, I write 2 electrons. 2 plus 2 is equal to 4 electrons. According to the rule, if a compound contains 4 electrons, it is anti-aromatic. So this organic compound is anti-aromatic. Thirdly, this organic compound is cyclic and it is also conjugated. We can see that this organic compound contains 3 double bonds. I write 2 plus 2 plus 2 is equal to 6 electrons. According to the rule, 6 electron means aromatic. So this organic compound is aromatic. Fourthly, this organic compound is cyclic and this organic compound is also conjugated. There are 2 double bonds. I write 2 plus 2 is equal to 4 electrons. 4 electron means anti-aromatic. So this organic compound is anti-aromatic. Now consider these organic compounds. We can see that this organic compound is cyclic. It is also conjugated organic compound. This organic compound 2 double bonds. I write 2 plus 2. For this negative charge, I write 2 electrons. Now 2 plus 2 plus 2 is equal to 6 electrons. We know that 6 electron means aromatic compounds. So this is aromatic compound. In case of this organic compound, we can see that this is cyclic organic compound and it is also conjugated organic compound. There are 3 double bonds. I write 2 plus 2 plus 2 is equal to 6 electrons. So this organic compound is aromatic compound. In case of this organic compound, remember that this organic compound is known as furan. It is cyclic and it is conjugated. We can see that this organic compound contains 2 lone pair of electrons. This lone pair of electron is outside the ring, so we do not consider it. This lone pair of electron is inside the ring, so we consider this lone pair of electron. So it is also conjugated organic compound. Now there are 2 double bonds. I write 2 plus 2. For this lone pair of electrons, I have to write 2. Now 2 plus 2 plus 2 is equal to 6 electrons. So furan is an aromatic organic compound. This organic compound is known as pyrrole. It is cyclic organic compound and it is conjugated organic compound. There are two double bonds. I write 2 plus 2. For this lone pair of electrons, I write 2, which is equal to 6 electrons. So pyrrole is aromatic organic compound. This organic compound is known as thiophene. It is cyclic organic compound and it is also conjugated organic compound. Remember that this lone pair of electron is outside the ring, so we do not consider it in the conjugation. There are two double bonds. I write 2 plus 2. For this lone pair of electron, I write 2, which is equal to 6 electrons. We know that if there are 6 electrons, it is aromatic compound. Lastly, consider pyridine. Pause the video and try to find it. Either it is aromatic compound or anti-aromatic compound. Well, it is cyclic organic compound. Secondly, this lone pair of electron is outside the ring, so we do not consider it. We can see that it is a conjugated organic compound. There are 3 double bonds. For these 3 double bonds, I write 2 plus 2 plus 2 plus 2, which is equal to 6. Here, remember that for this lone pair of electrons, I do not write 2 electrons because it is not participating in conjugation. 6 electron means aromatic compound. So this is aromatic compound. Thus noted down all these important examples of aromatic compounds and anti-aromatic compounds. Now let me teach you aromatic and anti-aromatic compounds in bicyclic organic compounds. Bicyclic organic compounds are those compounds when two rings are combined together. For example, consider naphthalene. It is a bicyclic organic compound because two rings are combined together. We can see that it is cyclic organic compound. Secondly, it is conjugated organic compound because it contains alternate single and double bonds. Here in these two rings, there are 5 double bonds. So I write 2 plus 2 plus 2 plus 2 plus 2, which is equal to 10 electrons. According to the rule, if a compound contains 10 electrons, it is aromatic compound. So naphthalene is aromatic compound. Secondly, consider pentylene. It is a bicyclic organic compound because two rings are fused together or joined together. This is cyclic organic compound and it is a conjugated organic compound because it contains alternate single and double bonds. Now inside these two rings, there are 4 double bonds. I write 2 plus 2 plus 2 plus 2, which is equal to 8 electrons. According to the rule, if a compound contains 8 electrons, it is anti-aromatic compound. So this organic compound is anti-aromatic compounds. Thus noted down these two important bicyclic organic compounds. Now we will learn the aromatic and anti-aromatic compounds and biphenyl organic compounds. Remember that biphenyl organic compounds are those compounds when two phenyl groups are bonded together. For example, consider this biphenyl organic compounds. In case of biphenyl, we will individually check each ring, either it is aromatic or anti-aromatic. In case of this ring, it is cyclic and it is conjugated. It contains 3 double bonds. I write 2 plus 2 plus 2, which is equal to 6 electrons. So this ring is aromatic ring. In case of this ring, it is also cyclic and it is conjugated. It contains 3 double bonds. I write 2 plus 2 plus 2 is equal to 6 electrons. So this ring is also aromatic. Thus both the rings are aromatic. We call this biphenyl organic compounds as aromatic organic compound. Remember that overall it contains 6 double bonds. 6 double bonds means 12 electrons. then we can say that it is anti-aromatic. But this is wrong, because we have to individually check each ring, either it is aromatic or anti-aromatic. So remember this important process. Finally, remember that aromatic compounds are highly stable. Then non-aromatics and anti-aromatic compounds are least stable. For example, consider this question. Arrange the following organic compounds in decreasing stability order. Well, in case of this compound, it is cyclic. Secondly, we can see that it contains double bond, single bond. At the third position, there is no negative charge, no positive charge, and no lone pair of electron, so it is not conjugated. Thus, this organic compound is non-aromatic. In case of this organic compound, it is cyclic and it is conjugated. There is one double bond, I write 2 electrons. There is one negative charge, I write 2 electrons. 2 plus 2 is equal to 4 electrons. We know that if there are 4 electrons, it is anti-aromatic compound. So this organic compound is anti-aromatic compound. In case of this organic compound, it is cyclic and it is conjugated. It contains 2 double bonds, I write 2 plus 2. It has also one negative charge, I write 2, which is equal to 6 electrons. We know that if organic compound contains 6 electrons, it is aromatic. So this organic compound is aromatic. According to the rule, we say that C is aromatic compound, so C is highly stable. A is non-aromatic compound, it is less stable than C. B is anti-aromatic compound, so it is least stable. Thus, this is the order of stability of these organic compounds. So this was all about aromatic compounds, anti-aromatic compounds, and non-aromatic compounds.